Alright folks, today our objective is to see what we can do working through this problem set. Now, first of all, let's go ahead and write down the problems that we were supposed to do. So, you were supposed to, let me make my pen just a little bit thicker here, and you were supposed to do 7-3, and this is day 1. Okay. Now, that is on page 509. We're supposed to do 2 through 13, 17 through 28, 33, 36, 38, 48, 50, and 54. Alright, so those are the problems you're going to work. We're going to start through this a little bit together, and I'm going to help get you started. And when you're all done with today's lesson, you're going to have all these problems finished. These problems are due at the start of the hour next class period. Alright, so let's go ahead and begin working on these. Okay, so let's take a look at our first problem here. So, at this point, you should have a piece of paper in front of you. You should have your textbook open. And we're going to walk through, and what's going to happen here is I'm going to walk through for example, the first problem in the set of problems, like 2, and then you're going to do 3, 4, and 5. So, let's guide you through problem number 2. So starting with number 2, it says, alright, so number 2, it says 2.4 to the 0 power equals 1. Now, we had to remember what our rule said first of all. Now, our rule said b to the x power equals a. Then, log base b of a equals x. Now, the little saying that I said, the base of the exponent becomes the base of the log. And then I stated that the inside, outside switch places. Okay? So we're going to use that, and we're going to convert this exponential equation into a logarithmic equation. Alright, so let's go ahead and look at this. Okay, so first of all, let's identify what is the base of the exponent. Well, the base of the exponent is 2.4. So the base of the exponent becomes the base of the log. So, let's write down. So we have log, and I'm going to put an equal sign there, and the base of the exponent becomes the base of the log, which means I'm going to put a 2.4 right there. Now, the exponent becomes the log. So that means this 0 right up here, this 0 right here, goes outside. It becomes the log. So the exponent becomes the log. So I'm going to write that 0 out there, and then that means this is written right there. So in other words, these two switch places. Okay, there's problem number 2. That's all there was to it. Now, I want you to use this one, and I want you to pattern it in doing the next 3 questions. So go ahead and pause the video, and I'm going to have you walk through 3, 4, and 5. Okay, now let's go to problem number 6 in your book. Okay, now problem number 6, we're going the other direction. Okay, so for problem number 6, it says log base 4 of 0.0625 equals -2. Alright, so let's remember. First of all, what is the base of the log? Right there. So the base of the log becomes the base of the what? Exponent. That's right. So the base of the log becomes the base of the exponent. And the logarithm, which is here, becomes the exponent. Okay, so I'm going to put -2 right there, and that equals 0.0625. Another way of saying it is the base of the log becomes the base of the exponent, and the inside-outsides trade places. There you go. Now, let's have you go ahead and work 7 through 9. Okay, pause the video and you work through 7 through 9. Okay, now let's take a look at number 10. In problem number 10, we're going to do a little mental math. Okay, and looking at problem number 10, it says log of base 7, and it's 343. Okay, so they want to know, what is the log of 343 base 7? That's equal to what? So I'll put a question mark there. Now let's convert it from logarithmic form to exponential. So I'm going to take this 7, which is the base of the log. It becomes the base of the exponent. So we're going to write a 7. Now whatever the logarithm is becomes the power up here, the exponent itself. So that's going to be our unknown. So 7 to the what power equals 343. Alright, so you have to kind of take your calculator, play with it a little bit. 7 to the what power equals 343. Now, if you're anything like me, I probably grabbed my calculator and went 7 times 7 times 7 times whatever to give me 343. That's what I did, because I knew it was going to be 7 to the some power equals 343. So 7 times itself, how many times equals 343? And when I did it, it was 7 to the third power equals 343. So that means that the log base 7 of 343 equals 3. All right. Now, you go ahead and try the next 3. 11, 12, and 13. All right, go ahead and pause it. Okay, folks, let's go on a little Easter egg hunt. Yay! You remember how we loved to do those when we were kids? Yes, I remember. Anyway, so go to Wikipedia, and in their search engine, I want you to type in the word logarithm. So LOGARITHM, logarithm. And I want you to write down verbatim Wikipedia's definition for logarithm. Now, when there's commas, make sure you have the commas. When there's periods, make sure you have periods. And when there is a bold-faced word, make sure you bold it. Yes, I mean bold it. And if there happens to be a blue word in that, and there's 2 of them, matter of fact, you get a blue pen and you write blue right there. Now, why am I having to go to that such a detail? Because it's an Easter egg. All right, go have fun. And by the way, it's worth 5 points to you. Extra credit. Don't tell your classmates. Oh, and you know what? Don't share your homework with them either. It's up to you to keep these 5 points. You earned them. Don't give it to them. If they didn't do their homework, they miss out. Alrighty. Well, let's get back to the lesson here today. But you go have fun first. Okay, folks. Now that we're done with having our little fun for today, let's have some more fun. So, from here on out, you're going to be doing 17 through 28. All right, so we've already talked about this, so I'm going to let you work through these. Now, when you finish those, then we're going to move on to 33. So, go ahead and pause the video for a second, and I'll come back at you after question 28. Okay, I'm ready to get started with number 33. You ready to get started with 33? All right, well, let's get started. Now, number 33, all it asks you is, it says, if the log base A of b to the 0, what is the value of b? And explain it. Here's the key to this question. Convert it from log form to exponential form. And when you convert it to exponential form, you have what b is equal to. and then just explain it. You can either explain it using the definition, or you can explain it using my little base of the log becomes the base of the exponents, inside, outside, switch. You call it. All right, you go ahead and write down that question number 33. Okay, done with that one? All right, let's take a look at number 36, and let me give you a little hint on 36. In doing 36, it says, given that the log of 100 equals 2, and the log of 1,000 equals 3, estimate the value of the log of 200 and the log of 500. All right, now, here's what I want you to do. I want you to convert each one of those to exponential form. For example, log of 100 equals 2. Remember, it's a common log. That means you're going to be 10 squared equals 100. Okay, that doesn't much look like 100. Let me try that again. All right, 100. Okay, now, then it says what in the second one? It says the log of 1,000 equals 3. All right, log of 1,000 equals 3. That means if you have 10 to the, what power? Well, the third power equals 1,000. Now, you're going to use that to estimate the value of log of 200 and the log of 500. Now, here's the key that I want you to kind of think about here. Remember, log 2 times 100 is 200. All right, so let's see if that helps you a little bit. So I want you to play with that a little bit, and you see what you can have. Oh, and by the way, when you get your answer, take your calculator, go log of 200, and see if you're close. Okay, but I want you to estimate first. Try to do it mentally first. All right. All right, now let's take a look at 38. Let me see if I can give you a few hints on 38. On 38, it says, explain why the log of 3 base 0 and the log of 3 base 1 do not exist. Here's a hint. Convert them to exponential form, and then look at it to see if it exists. If the exponent exists, if the exponential form exists, then the log exists. If the exponential form does not exist, then the logarithm doesn't exist. All right, so go ahead and play. Okay, it's time to do our last 3 questions. Now, the last 3 questions are from your spiral review, and they are questions 48, 50, and 54. Now, 48 and 50, if we look at those are using your property of exponents. So, remember, when you have a power to a power, you multiply. When you're multiplying common bases, you add. And when you divide common bases, you're subtracting. So if we take a look at 48, looks like the first thing I'm going to do is simplify what's inside. So when you push all that together, do you see any common bases? I don't. So you're just going to push it all together, multiply the 2 and the 5 together, and so on. And then you have those powers, the power of A and the power of B, raised to the second. Now, when you have a power to a power, what do? Right, you multiply. Okay, so I'll let you take it from there. Now, on that second problem, number 50 here, let's see here. Do you see some common bases? Now, that parentheses just means multiplication. So do you see some common bases? Well, you have a t to the second and a t to the negative 1. So when you have common base of t, what do you do to the powers? You're right, you add them, and then you just push everything else together, and I'll let you take that one from there. Okay, let's take a look at 54. Now, 54, you're using your calculator, and when you enter in 54, remember, you're going to set 0.6 in your calculator, then do the caret, and you're going to type in -2. Now, I recommend putting parentheses around anytime you enter in a negative. All right, and you're going to figure that chart out for -2, -1, 0, 1, and 2. And guess what, folks? That's going to wrap up this assignment. All right, next class, when you come together, probably won't have any time for questions, maybe just a few, but make sure you have this assignment all the way completed. And now, remember the odd ones are in the back, so if you want to check some of those odd answers, that's great. You can also come in the morning and check some of those even answers as well. And that's going to wrap it up for today. So long, farewell.